Hello, my name is Steven Sharaffa, and I am the CEO of Homeboys. This is Sharkbait, our first remote operated vehicle designed specifically for operating in the coastal waters off of the Pacific Northwest. This little ROV hits way above its weight class, built to excel in missions involving the search and recovery of wrecks, underwater installation and maintenance, and environmental monitoring and research. Sharkbait operates using 6 motors strategically placed on a rigid and hydrodynamic frame. It features 2 cameras positioned for the best view of any work environment, and Sharkbait's tether is neutrally buoyant and easy to manage, coupled with this propulsion system to allow for unrestricted maneuverability and stability for intricate work. I could go on and on about our vehicle's strengths, but now you're going to hear it from the team behind Sharkbait, starting with Kenny.
Hello, my name is Kenny Hellier, and I'm Chief Mechanical Engineer of Homeboys, and I'm going to be talking about our frame. So our frame is a very hydrodynamic yet versatile design. When designing the frame, we wanted something that would be very sleek, but would also be sturdy and interchangeable. By this I mean that you can add or take out any of the systems and change them as you please to whatever you want. Making the frame this way allowed us to have freedom to put the systems almost anywhere on the frame and mount them however we needed to. The frame is pretty much just an acrylic box with cutouts in it to make it hydrodynamic, but is very sturdy at the same time. But to make it even more sturdy, we added metal brackets to the edges to even further the strength. Overall, our frame design is very sturdy and has tons of ways to mount everything and anything you want. And now I'm going to pass it over to Cameron, and he will be talking to us about flotation.
Hello, I am Cameron Treckle. I am the head of Homeboys' Research and Development. Our ROV Sharkbait features 2 onboard cameras. One is located inside our pressure vessel, and the other overlooks the manipulator. Well, we're doing cameras. Both cameras, one camera is an infrared, and the other one is sees in color, and they're connected via a tether all the way to the control box that aids the pilot in maneuvering and task completion. This lets the pilot observe the movement of Sharkbait and the manipulator. Now I hand it off to Angel.
Hi, I'm Angel. I'm the Chief Propulsion Engineer and main pilot of Sharkbait. In the beginning of the project, we all took the time to learn programming with Arduino. We incorporated that knowledge into the construction of Sharkbait and have been allowed an invaluable amount of freedom because of it. We can control and change the way we control our propulsion and our manipulator arm. In addition, with a laptop and a computer and a printer cable, we can change the code on the fly if we need. And to begin the overview of the hardware on Sharkbait, we're going to talk about propulsion, or I'm going to talk about propulsion. Sharkbait is mainly propelled with 4 Blue Robotics T100 motors in the vector configuration. They are each paired with a Blue electronic speed controller from Blue Robotics, which are connected and controlled with an Arduino Uno R3. Sharkbait can move forward, backward, diagonal in each direction, and it can strafe and rotate. On Sharkbait are 2 bilge pump motors for vertical movement. All of them are shielded and shrouded. Due to power restriction in the Rager category, we cannot run each motor at full power concurrently. By default, we limit each motor to half power output. However, that limiter can be removed with the push of a button. And now I'm going to hand it off to Kenny again to talk about our manipulator.
The manipulator was one of the systems that was very important and very necessary to all the tasks that we had to do. Our manipulator features a 3D printed planetary gear system that makes it easy to replace parts if they break, and also they're strong and reliable. Along with the planetary gear being 3D printed, we also 3D printed the claw of the manipulator. This once again makes it so that we could interchange the parts, change whatever we need to, whenever we need to. In our task, we had to pick up different types of debris, so we thought the best design for this was to have 2 holes in the claw, which were 1/2 inch diameter and 1.5 inch diameter, so that it's just the easiest way to grab things. Also, while making our manipulator rotate 90 degrees so that it just has even more another field of variability. Overall, we believe that our manipulator is very versatile and it can do almost anything you need it to do, and you can also change it any way you want to by 3D printing whatever you need. Now I'm going to pass it over to Cameron again, and he's going to talk about flotation.
It would be camera, right? It would go flotation and camera.
Yeah. Alright, I'm going to speak about flotation. So contrary to our tech report, our ROV SharkBait utilizes a static ballast system, meaning it does not change its buoyancy at all. So due to poor time management, we did not have the time to implement the design we hoped for. However, our ROV SharkBait still performs at max capacity. So we have one syntactic foam block on top of the ROV, and it is rated at 500 kilograms per cubic meter, and it is 9 pounds. So it will lift 9 pounds of the ROV. We also have 2 PVC pipes located on the side to add buoyancy. As well, the pressure vessel we use to contain our electronics holds or provides some buoyant force. Now I will pass it off to Aaliyah to speak on Bluetooth.
Good afternoon, my name is Aaliyah Cruz and I am the Chief of Marketing for the Homeboys. We decided to use Bluetooth as our release mechanism to disconnect the OBS cable connector from the power and communications hub. Using Bluetooth allows us more leeway when performing the task because we have designed this system to operate easily at the push of a button. Once the receiver comes in range with the transmitter, at our command, the transmitter will send a signal to the receiver telling it to run the servo, which will pull the string attached to the piece of PVC we connected and release the OBS. We have constructed this mechanism using Arduino. I am now going to pass it to Joe, who will talk about safety.
Are we not going to talk about servo?
Is that after?
That should be after Bluetooth. And
I'm
then
sorry.
No
Okay,
problem.
well, we're
Alex
did
on
you
that
include? Yeah, did you include Alex on the list?
He's not on there.
Okay, Alex, you're going after me. All right. So now I'm going to tell you about servos. So various systems of our ROV use servos to function or complete tasks. For example, our OBS release system, which Aaliyah just described, utilizes a servo in which it detaches the flotation mechanism, allowing it to rise. In addition, we utilize servos to change the positioning of our manipulator, which Kenny told you about. It changes the angle to allow for more variability, as he said, in completing tasks and grasping objects. So servos, all in all, were a very affordable and accessible tool we had around our workspace, and it really solved a lot of problems to our innovative designs. Now I'm going to hand it off to Alex, who will speak of Tether.
Hi, I'm Alex Galletto, and I'm Chief of Tether. And for my initial plans for the Tether was to have a retractable coil, but after looking at concept designs, I realized our Tether would be thicker than expected. I found a more suitable system using a hose rail. The Tether is made up of 2 video cables and a video array, which controls everything. I wrapped them with hollow rope to give it more buoyancy. With the hose rail, it gives us a more efficient way of carrying the Tether with us. And now,
Whatever was after me, in the middle.
Joe. That should be Joe.
Joe?
I'll be having
I am Joseph Federation. I am the Chief Financial Officer of the Homeboys as well as the Chief Safety Officer. And I am going to be talking about our control system. Much like SharkBait, our control system was designed to be visually appealing and functional. We used a Pelican case as a way to keep everything contained, and inside this case are several simple circuits to control our vertical thrusters as well as the manipulator arm closing and opening. And there are also some onboard Arduinos to control the more complex parts of the ROV, such as the horizontal thrusters, the Bluetooth transceiver, and the servo to rotate the manipulator cloth. Our video monitor is is mounted inside the case in a convenient location so it can be viewed by the pilot and co-pilot who are operating the ROV. I have That's it. Who's next? I'm now passing it off to Doug. I'm just going to talk about our technical advancements.
Alright, my name is Doug. I am the Chief Operating Officer of the Homeboys, and I was kind of in charge of overlooking and had any questions they asked me during this whole endeavor. So here at the Homeboys, we are proud of what we accomplished in Sharkbait. Sharkbait is a highly maneuverable, functional, and aesthetically pleasing vehicle. It is built at a low affordable cost for all of us, and is capable of handling tasks in the Puget Sound, Seattle area. Each one of our systems is completely thought through to both connect with one another and complete our tasks at hand. At no point in the process of building our first Sharkbait did we not think about our tasks. We all thought that communication was a key strong point in this whole endeavor for us. This is why our vehicle is efficient and capable of completing its mission. At the Homeboys, we want you to know that care and thought was thoroughly put into the development of our ROV, both for our sake and for our customers. Our team members have spent countless hours perfecting Sharkbait, and we consistently came up with new, innovative ways to solve our problems during the evolution of our vehicle. I myself, as well as the entire team here at the Homeboys, are proud of our vehicle and confident in its capabilities. And I'll be passing it back to Joe to talk about budget, materials, and our safety procedures.
We took safety very seriously as we were constructing Sharkbait, and we made sure that any moving parts that would be exposed were shrouded and clearly labeled. We
I'm going.
We took care to waterproof any electronic components that would be near water, and we also made sure to include fuses in our circuits to ensure that if anything went wrong, they would fail first. For our budget planning with Sharkbait, we tried to keep it as affordable as possible. So we reused many of the materials that we have on there, including most of the electronic components, the bracings, the pressure vessel, the motors. The only parts we had to purchase out of pocket were things that we needed for the competition, such as lift bags so we could remove debris from the water, and a dome for the pressure vessel so that we could mount our camera inside it and have a good field of view. And we kept that theme of reuse versus purchase throughout the process because we wanted to save as much money as possible so we could afford being able to get here and to the international competition because we were going win or lose. And finally, I think that's about it. And I'm handing it back off to Steve to wrap things up.
So, I had a conclusion, but it's pretty much what Doug said.
Okay.
So,
Maybe you should talk to each other.
is that just it? You want me to say anything?
Can be.